Okay, in the last recording we looked at the first part of the fundamental theorem of calculus. The second part of the fundamental theorem of calculus shows us how to evaluate definite integrals. If f is continuous at every point of a to b, and capital F is any antiderivative of f on a to b, then the integral from a to b, f of x dx, is capital F of b minus capital F of a. In other words, we evaluate our antiderivative at b and subtract off what we get when we evaluate our antiderivative at a. So let's look at a few examples here of how these can be evaluated. We have the integral from 0 to pi of cosine of x dx. Now remember, if you look back, there were a set of tables that showed us some of the antiderivatives. For cosine x, the antiderivative of cosine x is sine x. Now here's how we are going to write these problems. Okay, the antiderivative of cosine x is sine x, since the derivative of sine x is cosine x. And we're going to put what looks kind of like a closed bracket, and we're going to evaluate this between 0 and pi. Okay, so we put our antiderivative here, our lower limit here, our upper limit here. And then remember, it said we're going to do the antiderivative at the upper limit minus the antiderivative at the lower limit. So we will take sine of pi minus sine of 0. Well, the sine of pi is 0 minus the sine of 0 is 0, and that gives us 0. So the integral from 0 to pi of cosine of x dx is 0. Now let's look at the one at the bottom. We have the integral from 0 to 1/2 dx square root of 1 minus x squared. Now if you look back to those antiderivative formulas, this is the derivative for inverse sines. The derivative of inverse sine of x is 1 divided by the square root of 1 minus x squared. And we're going to take this between 0 and 1/2. Okay, which means we're going to do the inverse sine of 1/2, and then you always subtract off the function value at the lower limit. Well, the inverse sine of 1/2 means what angle between negative pi over 2 and pi over 2 has a sine of 1/2, and that would be pi over 6. Inverse sine of 0 means what angle between negative pi over 2 and pi over 2 has a sine of 0, and that would be 0. So pi over 6 minus 0 is pi over 6. Okay, let's do one more. We want the integral from 1 to 4 of 3/2 square root of x minus 2 over x. Okay. Now remember, we talked about if we make square roots into exponents, we can use the power rule. Okay. Now we want to find the antiderivative of 3/2 times x to the 1/2. Now the antiderivative, remember, is what you get when you add 1 to the exponent, which is 3/2. Now let's think about this. If I just had x to the 3/2, that would be 3/2 as a coefficient, subtract 1, x to the 1/2. So I don't need any kind of a coefficient out here in front in order to take this derivative and come up with this. Now remember, for this is 2 times 1 over x, and the derivative of antiderivative of 1 over x is natural log of x. So this is minus 2 natural log of x. Okay, 2 times the derivative of natural log of x is 1 over x, and we're going to take this between 1 and 4. Now be very careful when you evaluate, because you're going to evaluate the first one, 4 to the 3/2 minus 2 natural log of 4, and then you're going to subtract 1 to the 3/2 minus 2 natural log of 1. Make sure that when you do your subtracting, that you subtract the 1 to the 3/2 and you also subtract the negative 2 natural log of 1. Okay, so you've got to make sure that that negative distributes through and it changes both of the signs. Now let's think about 4 to the 3/2. 4 to the 3/2 means the square root of 4 cubed. Okay, remember that 3 is the power, the 2 is the exponent. Now here, just to simplify a little bit, think about your logarithmic rules, and any coefficient is an exponent, so this is natural log of 4 squared. Remember, you can bring your coefficient in, make it an exponent. and then of course we have the square root of 1 cubed minus, or plus, because it's minus negative, plus 2 times the natural log of 1 is 0. So I do the square root of 4 is 2, and 2 cubed is 8, minus the natural log of 4 squared, which is 16, minus the square root of 1 is 1, 1 cubed is 1, plus 2 times 0, which is 0, and that gives us 7 minus natural log of 16. Okay, now, if we actually want to be finding area under curves, or area between a graph and the x-axis, you've got to be very careful. If I just evaluate this integral, I'm going to come up with 0, because it's going to find this area to be 2 and this area to be negative 2. And technically it's not an area because the area can't be negative, but it's going to find this integral to be 2, this integral to be negative 2, and so the entire integral will be 0. So you've got to be very careful, because if there's parts that are above the axis and parts that are below the axis, to actually find the integral, or to find the area, we will want to find the integral between 0 and pi, and the integral between pi and 2 pi, and this integral we'll want to take the absolute value of. Okay, because if I just do from pi to 2 pi, then I'm going to get a negative 2, and I don't want negative, I want an actual area which is positive. So if I want to find the area here, I'm going to take the integral from 0 to pi of sine x dx. That's going to give me this area in blue, plus. Now here, notice I'm going to put absolute values around this. I'm going to take the integral from pi to 2 pi of sine of x dx. Now, all that in the absolute values. Okay? Well here, when I do this, we look at sine x. Remember, the antiderivative of sine x is negative cosine x. And we're going to take that between 0 and pi. Plus, I'm going to take the absolute value here. The antiderivative is negative cosine x, and we're going to go between pi and 2 pi. We're going to take the absolute value of that. Okay, so that means it's negative cosine of pi minus negative cosine of 0 plus, of course we've got the absolute value here again, negative cosine of 2 pi minus negative cosine of pi. And all that's in the absolute values. Now the cosine of pi is negative 1. So I have negative 1 minus negative, and the cosine of 0 is positive 1, plus negative cosine of 2 pi is 1, minus negative cosine of pi is negative 1. Now there's lots of negatives, so you've got to be extra careful here. Negative 1 is 1, minus negative 1 is plus 1. And in the absolute values I've got negative 1, I've got minus, negative, negative. 3 negatives will make that a minus. This gives me 2 plus the absolute value of negative 2, which is 2 plus 2 or 4. The actual area between the curve and the x-axis here is 4. This area is 2. When you compute this integral, you get negative 2, but the area is actually positive 2. Now, when we want to find the area between a graph and the x-axis over some interval, we need to subdivide that at the zeros of f. So we've got to make sure that we are looking at that correctly. We're going to integrate f over each subinterval, and we're going to look at the absolute values. If they're positive, you're okay. But if any of the integrals are negative, you're going to have to add there. Okay, now let's take this graph. Y equals x cubed minus x squared minus 2x. You can see that it has a 0 at 0. Okay, if we want to look between negative 1 and 2 here, we'll need to look at between negative 1 and 0, and it's going to be a positive answer. And then look between 0 and 2. It's going to be a negative answer, so we will need to take the absolute value there. Okay, so we're going to have the integral from negative 1 to 0 of x cubed minus x squared minus 2x dx plus we're going to have to take the absolute value of the integral between 0 and 2 of x cubed minus x squared minus 2x dx. Now that's going to be an absolute values. Now we need to take the antiderivative. It's going to be the same either way. Now 1 more than 3 is 4, so we know we have x to the 4th. But now if I took the derivative of x to the 4th, that would be 4x cubed. So remember it said we had to do 1 over n plus 1. So 1 over 3 plus 1 is 1/4. That way, when we take the antiderivative, 4 times 1/4, or take the derivative, 4 times 1/4 is 1x to the 3rd. Same thing here, I'm going to have x cubed. So I have to put a 1/3 in front of it, so I can say 3 times 1/3 is 1. And the antiderivative of 2x is x squared. Okay, we're going to look at that between -1 and 0. Okay, then we're going to do exactly the same. 1/4 x to the 4th minus 1/3 x to the 3rd minus x squared. And we're going to go between 0 and 2, and we're going to look at the absolute value of that one. Okay, here we're going to plug in 0 first. So that's going to be 1/4 times 0 to the 4th minus 1/3 times 0 to the 3rd minus 0 squared minus. Now here we are going to take 1/4 times -1 to the 4th minus 1/3 times -1 to the 3rd minus 1/3 times -1 to the 3rd minus -1 squared. Okay, plus, I'm going to have to put this on 2 lines here. It's all in the absolute values. It's going to be 1/4 times 2 to the 4th minus 1/3 times 2 to the 3rd minus 2 squared minus, and then we plug in 0, 1/4 times 0 squared minus 1/3 times, 1/4 times 0 to the 4th minus 1/3 times 0 cubed minus 0 squared. Now all that's in the absolute value, the second part. Okay, now let's look here. This is going to be 0, this is going to be 0, this is going to be 0. This is going to be 0, this is going to be 0, this is going to be 0. So let's just look at what's not going to be 0. Okay, so I've got -1 to the 4th is +1. So 1/4 times 1 here. And I've got the negative sign, so that first part's -1/4. I've got -1 cubed is -1. So I've got -1/3 times -1 is 1/3. But I've got the minus sign here, so it's also minus. -1 squared is 1. So I've got -1 times this minus is a +1. Plus, we're going to take the absolute value here of 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16, and 1/4 of 16 is 4. Minus 2 cubed, 2 times 2 is 8, so that's 8/3. And then minus 2 squared is -4. Okay, now let's collect all of our like terms here. -1/4 minus 1/3 plus 1. If you'll get a common denominator, it's going to give you 5/12 plus, now this is 4 minus 4, so we've got the absolute value of -8/3. Okay, and so this is 5/12 plus 8/3. Okay, now remember 8/3, you have to multiply the top and bottom by 4, so it'd be 32/3, so that's 37/12. So the actual area here is what we get when we add 5/12 plus 8/12, which is 37/12.